Your hidden layers are considered something like your original raw features. Your raw features, it's trying to map as a linear combination of your raw features, x1, x2, x3. Okay, as a linear, because these weights are getting a product x1, w1, x2, w2, x3, w3. You take a sum of products as a linear combination of your input features. You get a sum. Again, you suppose if you have more neurons in the hidden layer, another linear combination of these input features, you get a linear combination of the input features. You try to map your input feature with some operations. Of course, here you're doing a linear operation with a non-linear activation. Non-linear activation. So the popular choice of activation functions are tan h, sigmoidal function. Okay, these function has a non-linear activation so that you are projecting your raw feature to a newer transformation plane, and you try to see that in the transformed plane whether your data is separable or not. So ultimately, assume that if you have only one hidden layer, finally your output layer will try to solve this. Okay, whenever you are mapping one class of record, whether it is able to increase the probability of one node, say imagine it's like a binary class model. It is trying to increase the probability of this node. Another set of data when you present over here and you try to map onto the hidden layer. Hidden layer is considered as a transformed representation of your original raw features, and your output layer try to maximize the probability of this node for the second class. If it is successfully, it is accomplished that and able to reduce the error. With one hidden layer itself, you are able to solve the problem. Even after the transformation, if your output layer struggle to reduce the error function or maximize the probability, okay, maximize the probability. Whenever you maximize the probability, we used to call this a maximum likelihood. Maximum likelihood means for class 1, okay, the likelihood of these nodes should reach the probability score close to 1. For class 2, the likelihood of the probability of this node to be 1. So when you maximize the probability, the overall the cross entropy will be reduced.